In this video, the theorem gives us that we have this set of vectors, set of non-zero vectors in the vector space V. And every set has a span. And the span of S we're going to call W. Then we want to show that there must be some subset of S that is the basis for W. Okay. So now, I guess there's two cases. Case one, S is a linearly independent set. Now, to be a basis for W, two things have to be true. Be true about a set. It has to span S and be linearly independent. Since the span of S equals W, and S is a linearly independent set, we have that S is a basis for W. Okay. Case 2. S is not a linearly independent set. That is, S is a linearly dependent set. By an earlier theorem we know, then there exists some V sub j in S such that V sub j is a linear combination of the earlier vectors of V1, V2, up to Vj minus 1. So let S prime equal S minus V sub j. The span of S prime is still W. If S prime is a linearly independent set, then we're done. Then we have that S prime is a basis for W. Because again, to be a basis, for S prime to be a basis for W, S prime must be linearly independent and it must span W. Okay, and we have that. Okay. If S prime is linearly dependent, then there exists, I don't know, a V sub k such that V sub k, and k is clearly bigger than j, there exists a V sub k such that Vk is a linear combination of the preceding vectors of V1, V2, up to Vk or minus 1. Let me say here, was k bigger than j? J being the Vj from their step before. Okay, so now So how about we say let S double prime be S prime minus V sub k. That is, it's S minus Vj and Vk. We remove those two. If S double prime is a linearly independent set, then we have that S double prime is a basis for W. If needed, we can continue. But this process must end since S is a finite set. So eventually we will have an independent set because we just keep removing one by one. We keep removing one by one until we have a linearly independent set. That completes this proof. If you like watching videos like this where we prove theorems, subscribe to my channel. Most of all, please watch and learn, and I hope to see you in the next video.